This is Chapter 4, Section 5, number 39, linear approximations and tangent line approximations. And this problem is going to be looking at the idea of an over approximation or under approximation. So we have the function e to the minus x, and we want the tangent line approximation at ln of 2. So ln of 2 is the point of tangency. So that's going to be our x1. To find our y1, we have to plug that into our function. Here's when we have to do some fancy algebra. Remember the p in front of the log, we can move that p in front of the log or vice versa. So that's going to get us e to the ln of 2 to the negative 1 because there's an imaginary 1 there that you don't see. And that becomes 1/2 because you reciprocal that. And e and ln are inverse functions. They cancel out, leaving you with 1/2. So our x1, y1 is going to be ln of 2, 1/2. So that's going to be our point of tangency. Now we're going to need our slope. And the derivative gets us a slope. And the derivative of e to the box, I am my own grandpa, times the derivative box. So we get this for the derivative. But to find the slope at the point of tangency, we need to plug in that 2 again. Well, we did this before. This came out to be 1/2. So that's going to be 1/2, but there's a negative, so it's negative 1/2 for the slope. That'll be the slope at the point of tangency, and we're going to have this equation. Plug in our x1, y1. And we also have the slope, which we just found, which is negative 1/2. Add 1/2 to the other side. So that is our tangent line approximation that we will use. And we can write like this if you want to. So what just happened? Let me get a visual of this. So the black line, that's minus, or e to the minus x. This must be, I don't know, ln of 2 is somewhere, our point of tangency is around there. And so they ask, if we use this to approximate, is it over approximation or under? Now clearly any point you choose is going to be less than the actual value. So clearly the red line, any point on the red line is going to be under the actual value, so it's an under approximation. But how would you do this if you didn't know what the graph looked like? And so that's where the second derivative is important. We found the first derivative of the function. Then we find the second derivative, and I am my own grandpa times the derivative box. And then we're going to end up with the second derivative being e to the minus x, because these are going to cancel out. Now, knowing the graph of e to the x, which you should all know, it's never negative. It's always above the x-axis. So no matter what you put for x, that's always going to be positive. And since the second derivative is positive always, that means you're going to have an under approximation. So that's what you have to know. If the second derivative is positive, you're going to be under. If the second derivative is negative, meaning concave down, your tangent line approximation is going to be over.